Despite the recent scientific revelations surrounding our understanding of Neanderthals, there are archaic connotations with the topic that can make us think of brutish, savage humans. That classic image of a Neanderthal might pop into your head, of an ape-like man dragging his knuckles as he carries a wooden club. In reality, this was far from the truth, and we may know now that Neanderthals were more like us than we could ever imagine. They survived, communicated, played, and even loved like modern humans do. They were simply another branch on our family tree, rather than a step back in time. There is much over the years of studying Neanderthals that scientists have been able to find out about their social lives, their relationships, family lives, rivalries, religions, and even romance. These discoveries have changed the way we look at Homo neanderthalensis, allowing us to get a unique perspective into their lives. In some instances, we've gained a very human perspective into a species that was once perceived as very different from us. Today, we will be exploring these relationships, romantic and beyond, discovering what we know about how Neanderthals loved and bonded with one another. The most important fact we know about Stone Age relationships is that today, modern Europeans and Asians have, on average, 1 to 2% of Neanderthal DNA in their genes. This isn't a coincidence or an evolutionary trait. It's direct evidence that, on a large scale, early Homo sapiens interbred with Homo neanderthalensis. Not all relationships in the Stone Age, it would seem, were purely Neanderthal-Neanderthal or human-human. Individuals outside of Europe and Asia seem to have significantly less Neanderthal DNA in their genes, or none at all depending on their ancestry. Modern Africans, for example, tend to lack Neanderthal genes, as much of this interbreeding occurred in the groups of humans that had migrated outside of Africa and into Eurasia. Across the regions Neanderthal lived historically, their DNA lives on to this very day then. So, at some point in the late Pleistocene, out on the windswept plains of the vast European mammoth steppe, a Neanderthal man and a human woman, or vice versa, perhaps stumbled across one another while foraging for their respective family groups. With sensitivity, we don't historically associate with species that aren't our own. The Neanderthal may have made an effort to woo his newfound partner, although it is unlikely that they spoke the same language, if Neanderthals could speak at all. Perhaps a series of grunts and body language led to intimacy, and they soon discarded their furs to lay together in a sheltered clearing. This is a fictitious encounter, of course, but it's firmly based on fact. Encounters like this would have been common enough in the Pleistocene for remnants of the DNA of Neanderthals, despite belonging to a species that is entirely extinct in the modern day, clings on. This couple would go on to raise a baby, their offspring being a human Neanderthal hybrid, combining traits of both species. Perhaps, like Neanderthals, their child would have a prominent brow ridge and bulky stature, whilst retaining the height and dexterity of their human parent. This in turn raises so many questions. Did the father and mother stay together, or did they immediately go their separate ways? Was the child capable of language acquisition depending on who raised it? How did being a 50-50 hybrid impact this individual's life growing up? Sadly, these are questions we may never know the answer to. What does having Neanderthal DNA mean for us in the modern world, though? Despite the small amount of Neanderthal DNA left in our genome today, it might actually have notable impacts. It is thought to influence various aspects of our physical appearance, including hair color and texture, height, the strength of our immune system, how well a human is able to cope with a high altitude, and how strong their sense of smell may be, as a few examples. The biggest of these factors is the impact Neanderthal DNA may have on our immune system. The amount of Neanderthal DNA in our genome may directly impact how at risk we are from developing certain diseases, or being able to fight pathogens in our system. This is still an area scientists are only beginning to understand, and there's much more investigation to be carried out if we are to truly understand how our Neanderthal heritage affects us directly in the modern world. The origins of investigating Neanderthal-human interbreeding come from a discovery made in the Peștera Cuoase, a cave system near what is today the Romanian town of Anina in the southwestern Carpathian Mountains. Scientists investigating the cave in February of 2002 stumbled across something that would revolutionize our understanding of ancient humans. Even getting into the cave was a challenge. The researchers immediately found themselves neck-deep in water, trudging through an underground river flowing through the pitch-black cave network. What followed was a 30-meter scuba dive, followed by a 300-meter climb into an opening in which a new chamber could be explored. What they found was an Ice Age researcher's gold mine. Thousands of mammal bones littered the chamber floor in what was thought to be a cave bear den. In the Ice Age, the water would not have blocked the bears from entering the cave, and this secluded network made for the perfect hideout. Amidst the mountain of bones was a strange jawbone, one that clearly belonged to a human, but had features more closely associated with Neanderthals. This was not a human that was killed by bears and brought to the cave, but one who had died outside the cave, having been washed in when the river began to flow. Noting the unique find, the researchers extracted the bone from the cave, suspecting that this might in fact be evidence of hybridization in our very own species. Years later, in 2015, their theory was confirmed when DNA sequencing showed that this human had as much as 9% Neanderthal DNA. It is thought that this person had a pure Neanderthal ancestor between 4 to 6 generations prior to their existence, and that the interbreeding took place less than 200 years before this individual was born. These interactions between humans and Neanderthals appear to have been commonplace, at least commonplace enough for their DNA to still be visible in us today. Hybrids may have been common enough that they did not struggle to integrate into Neanderthal or human societies, but of course there is very little evidence to say one way or another about this in the fossil record. Eventually, the Neanderthals would become extinct, and a leading theory as to why is that our genome essentially consumed theirs. Interbreeding may have become so common that hybrid Neanderthals soon became interchangeable with humans as their numbers dropped and human populations increased. So we know that Neanderthals interbred with humans, but what were social and romantic relationships like between these couples? How did they interact, and is there any evidence to suggest that these relationships were affectionate? Remarkably, there may be evidence for kissing in the fossil record, in an amazing study conducted by Laura Wyrick, an anthropologist with Pennsylvania State University in 2017. Much of Laura's work has previously focused around Neanderthals' diets and ecology, and this study involved sequencing DNA from the fossilized plaque that had built up on the teeth of Neanderthal specimens. Samples from 3 European caves were used, but the ones from El Cedrón cave in northern Spain proved to be the most intriguing. The El Cedrón Neanderthals were some of the last Neanderthal specimens to walk the earth. Their DNA showed extensive histories of interbreeding with modern humans, and their wider skeletons were racked with abnormalities, misshapen bones, baby teeth found in adults, and distorted vertebrae. Moreover, cut and tooth marks on their bones show that when they died, they were cannibalized by those living in the same cave. They were desperate individuals on the verge of extinction, the last members of their species in a world that had been overrun by Homo sapiens. One of the teeth in Laura's study contained traces of Methanobrevibacter oralis, a microorganism found in modern human mouths. The Neanderthal microorganism differed slightly to the modern variant, which allowed Laura to determine that the two variants had separated about 120,000 years ago. What's more, however, is that this bacteria seems to have been transferred from human to Neanderthal at some point during the human's evolutionary path. This may or may not be evidence that relationships in the Stone Age were much more affectionate than previously thought. This may be genuine evidence that during moments of closeness, Neanderthals kissed one another, transferring the microscopic organisms living in their mouths from individual to individual, and occasionally across species to modern humans. It may, however, be evidence of something else entirely. Oral microbes can be transferred from person to person if food is shared. Perhaps interbreeding Neanderthals and humans lived with one another, sharing their spoils of foraging and eating together. Other studies have shown insights into Neanderthal sexual relationships, which show a dark side: the transmission of diseases via intimacy with humans and Neanderthals alike. Researcher Vil Pimenoff, undertaking studies on the sexually transmitted disease human papillomavirus, or HPV, has noticed some strange trends in the virus which date back to the times when our ancestors were breeding with Neanderthals. The patterns of different types of HPV, for example HPV A, B, and C, correlate with the amount of Neanderthal DNA present in people across the globe. HPV type A, the most common, is associated with individuals with Neanderthal DNA present in their genomes, whereas HPV B and C are more commonly found in modern Africans who lack the Neanderthal influence in their genes. HPV-A appears between 60 and 120,000 years ago, when humans were beginning to filter out of Africa and into Eurasia. It is thought that Neanderthals and humans might have been swapping diseases as they bred with one another, and HPV has remained in circulation throughout humans in the world today. Vil undertook extensive research into this idea, and the results always supported this theory. Moreover, HPV was not spread to one human once, but to many humans across many different instances, which further reinforces the idea that this was the product of frequent breeding between humans and Neanderthals. Without a time machine, it can be difficult to discern the specifics of Neanderthal relationships with either humans or their own species. There are several theories that have been put forward as to how Neanderthal relationships worked, logistically speaking, however. It is thought that the male in any given Stone Age relationship, whether human or Neanderthal, would determine where the couple lived. Couples may have settled down if they chose to partner up long-term, near to where the male's tribe or homeland was, and family groups were formed. If a family group could be established in the long term, females would most likely leave the group to search for a mate when they reach maturity. Neanderthal babies were breastfed for around 9 months and were weaned at around 14 months. Older women typically bred with younger men, which has been discovered as the Neanderthal genome was fully sequenced. If couples stayed together, they likely would have both taken part in the day-to-day survival efforts of the group they were a part of: foraging, hunting, crafting, and taking care of their children. They may have practiced basic belief systems or religions together, may have laughed and played with one another, and if they could, spoken about their world and the plants and animals living within it. Physical contact, just as it is in humans and modern great apes, may have been commonplace. We know that Neanderthals crafted and wore jewelry made from bones and minerals in their environments, but whether or not this was intended to make the wearer look more attractive to a partner remains to be known. As Neanderthals become few and far between towards the end of the Pleistocene, interactions like this became less and less common. The last remaining populations of pure Neanderthals would have suffered from congenital defects, on accounts of their small populations and difficult lifestyles. Eventually, their genes were absorbed into our own, and all that is left of the pure Neanderthals is their bones and the slivers of DNA that remain in our genomes today. That being said, there is every reason to believe that love prospered in the Stone Age despite the harsh conditions. Intimacy and physical touch were common, and after all, Neanderthals were human. They may have expressed their love in many different emotional and physical ways that have since been lost to the fossil record. Perhaps one day, as more evidence is uncovered, we will learn exactly what it was like to love and form relationships in our distant past.